Okay, hi guys. So in this lecture, we'll be starting off with Charles' law or Charles' law, whatever you want to call it. Pronunciation that does not matter. Okay, so before that, we can actually have a look at the equation which we look in the previous lecture. So one log p which was equal to log k minus log 1 upon v, or we can write log p as log k plus this is log minus log v and plus log 1 upon v. Okay, so we can see the graph for the two. Suppose we have to draw the graph between log p and let's say log v. So between log p and log v it would have a minus slope. Okay, and initially log p would be having value of log k, and now if we have to draw the graph between let's say log p and log 1 upon v, then it would be a positive slope graph. Okay, and the initial intercept would be in log k. Okay, so now let's start with Charles' law. So we know that PV equals to nRT. So Charles' law says that for a fixed amount of gas at constant pressure, volume is directly proportional to the temperature. So let me write down the statement first, that for a fixed amount of gas at let's say constant pressure, volume of gas is directly proportional to the temperature of gas. Okay, or in other words, V is directly proportional to T, or we can have a look that V would be equals to KT when removing the proportionality sign, and where obviously K would be equals to NR upon P. Okay, so let's say this temperature is in Kelvin, so we can convert this. Let's put the value of K as NR by P, and temperature in degrees Celsius plus 273 Kelvin, 273.15 Kelvin, let's be exact. Okay, so this is the relation between volume and temperature in degrees Celsius. So now let's draw some graphs, some exciting graphs on the same. Let's say temperature is in Kelvin and V is on the y-axis. What would be the nature of the graph? Again a straight line. The slope would again be equals to K, which would be equal to NR by P. Okay, so from this equation we can write that at 0 degree Celsius V would be equals to NR by P times 273.15. Okay, so we can write that this is V naught. We are just representing V at temperature 0 degree Celsius as V naught. Okay, so we can write that NR by P is nothing but V naught by 273.15. Okay, so from here we can get to know the value of constant, which is nothing but volume of the gas at 0 degree Celsius divided by 273.15. Let's look at another graph where we have to compare V naught, again the same graph. So actually at 0 degree Celsius the volume is V naught, so it would not be starting with, so okay, for Kelvin it would be starting from 0, because at 0 Kelvin we have volume as also 0. But what happens when we look at temperature at 0 degree centigrade, and y-axis we have volume. So on x-axis we have temperature in degree Celsius, and on y-axis we have in volume. So when we have 0 degree Celsius, then the volume is V naught. Above that we have the slope. Okay, slope remains the same, which is equals to nothing but nr by p. Only the intercept part changes, and when the temperature is minus 273 degrees Celsius, then we have volume as 0. So this is minus 273.15 degrees Celsius. Okay, so this is the graph or difference in graph from the first case to the second case. So we can make a note that here, that at minus 273.15 degrees Celsius or 0 Kelvin, volume of ideal gas is 0. Okay, so we write that V equals to KT, and we know that K would be equals to NR by P. We are taking T here in Kelvin. So what would be the nature of graph between V upon T and let's say T or V? So we know that V upon T would be again equals to constant, hence Y intercept would be equals to NR by P. It doesn't matter what the axis we choose, whether we choose T or V, it doesn't matter. What would be the nature of graph between V by T square and 1 by T? So we know that PV equals to, rather V equals to KT. So just divide on both the sides by T square, this becomes Y and this becomes K by T. So this equals to Y equals to mx. So this would be a straight line. Okay, and again slope would be equals to K. Okay, let's discuss another graph between Vt and T square. So we know that V equals to KT, just multiply T on both the sides. So this becomes x-axis, this becomes y, so y equals to mx, again a straight line. Okay, and slope again is equals to K, which is NR by P. Let's take a look at another graph. We have Vt on y-axis and T on x-axis. So we know that V equals to KT, multiply on both the sides with T. So we have Vt equals to KT square. So this is y equals to mx square, which is nothing but a parabola equation. So this would be the nature of graph, where K would be equal to NR by P. Okay, let's say what would be the graph between again V and under root of T. Again it would be a parabola. Why? Because V equals to KT, and as under root of T is x-axis, hence T would be x square. So y equals to again mx square is the equation that is coming here. So again this would be a parabola, again with slope equals to NR by P. So we know that V equals to KT. We have seen it so many times in this video lecture. Let's say we take log on both the sides. V equals to KT, log K plus log of T. Okay, so what would be the graph between this is log of V, rather log of V and log of T. Again it would be having intercept as log of K. Okay, and from there on it would be a positive slope. So with this we come to the end of this lecture. In the next lecture we'll be continuing on more gas laws, and we'll be basically looking into Gay-Lussac's law. So till then, good luck and goodbye.